Good morning, children. Today we will take the refining process of the crude metal. Okay. Crude metal, when you obtain from the extraction process after you have reduced the oxide of the metal into the metal, that is what we call as the crude metal. That crude metal have to be refined because that crude metal still will contain some amount of impurities which has to be removed. Okay. And that process will be called as the refining process. There are various refining process depending on the type of the metal which you have. The metals with low boiling points or low melting points will be refined by a particular method, and the other ones will be refined with other refining processes depending on the nature of the metal. Okay? So, first refining process is what we call as distillation. Okay? Distillation process. Now, distillation process mein what is occurring? This metal is converted into its vapor form, and then that vapor is condensed so that the liquid metal which you have now is a pure form. So, the impurities which were present in the metal will not get converted into vapor form because their boiling point will be different from that of the metal. So, metal with low boiling points, you can do the refining process by distillation. You just heat the metal, bring it to that boiling points where the metal will convert, the liquid metal will get converted into the vapor form. That vapor is then condensed, and that condensed vapor will be collected. It is then it will be liquefied solid form can be obtained from that. Okay? That is distillation process. Okay? And distillation process you carry out for metals like zinc, mercury, cadmium. Okay? You carry out distillation for metals like zinc, mercury and cadmium. Okay? That is low boiling mixtures. Okay? The second process is liquefaction process. Okay? It is liquefaction process. Liquefaction process mein what is done? There is a sloping hearth this way. Okay? This is where you put your feed, that is your crude metal. Okay? And here you are providing with high temperature. Now, metals which have very low boiling points, what will happen? It will get converted into the liquid form, that is the metals with low melting point. It will get converted into the liquid form and it will just roll out and get collected in the vessel, while the impurities will stay at the top only. Okay? So, metals which are having very low melting point, just like zinc or which are the other metals which you are obtaining in this way. Lead is there, tin is there. Okay? Metals like lead and tin. Okay? Metals like lead, tin are purified in this manner. Lead, with impure lead you just drop it here, and here you are providing with high temperature, the lead will melt out and get collected over here, while the impurities will stay at the top. Okay? So, here impurity will remain as it is, and here you will obtain the pure metal. This is the method what we call as liquefaction process. Okay? This is liquefaction. Next, what is the next type of refining process? It is the electrolytic refining. Electrolytic refining can be carried out for different metals like copper hai ya iron hai. They all can be purified with the help of electrolytic refining. Now, in electrolytic refining, how is the process carried out? Electrolytic refining mein you take a vessel, okay, or a tank you can say, because when we are talking in a large scale there will be a big tank where you place the impure metal. You will take it as your anode. This is your impure metal. okay, impure metal, it will be broad strip, okay, broad strip, and this should be taken as your anode. Anode means you will connect it to the positive terminal of the source, and you will have the thin strip of the pure metal, okay, a thin strip of pure metal you will take and you will connect it to the negative terminal behaving as your cathode. So what will happen, the metal will dissolve and you will take the electrolyte, suppose copper है तो copper sulphate ले लेंगे, lead है तो lead sulphate ले लेंगे, तो copper sulphate from the solution will start depositing on the pure copper, okay, suppose this is your pure copper, okay, and this is your impure copper. So what is happening, the copper will get dissolved as Cu plus 2 ions, okay, and in the solution this electrolyte you will take it as CuSO4 solution, and in the solution you have Cu plus 2 ions and SO4 2 minus ions. So this Cu will convert to Cu plus 2 will get converted to Cu and get deposited here, okay. So here Cu will move into the solution, anode में क्या reaction होता है, anode में you will get Cu getting converted to Cu plus 2 electron, और cathode में क्या होता है, cathode में you will have the reaction Cu plus 2 which is present in the solution form, it will take the 2 electron and get Cu solid, followed. So ये Cu goes on getting deposited and at the end of the reaction you will find that this strip has become broader while the anode will become thinner. The impurities will be collected at the bottom, okay. So this is how you are carrying out the refining process of any metal. Anode में impure metal ले लेने का और cathode में pure metal ले लेने का, okay. So this is the electrolytic refining process, okay. The next type of refining process is called as zone refining process. यहाँ पे the principle behind this refining process is that the metal have less solubility in their melt, while the impurities are more soluble in their melt. So actually what is done here, there is a device or an apparatus of this kind, a setup of this kind. This is an experimental setup where you will find this kind of an arrangement, okay, and you are having the impure metal in the form of a you will take it in the form of a bar, okay. There are circular heaters which keep on rolling in one side. These are circular heaters. These are circular heaters. So these circular heaters will keep on rolling over one side, heating the metal which is kept above. This is an inert atmosphere, okay. It is kept inert atmosphere. So what you will find? There will be a region where there is a melt of the impure metal. Melt means what? That metal bar has, this is impure metal suppose, okay, impure metal. अब ये जो circular heaters है, this is making the impure metal convert into the liquid form, into the melt form. So these circular heaters have made the impure metal bar to convert into a melt, but as the temperature is decreased to this side, because circular heaters are moving at this region, you will find this is the impure bar which you have taken, ठीक है. अब circular heaters ये impure bar को metal melt में convert हो जाता है, it converts into the liquid form. अब this melt no, ये जो melt हम कह रहे हैं, it has metal plus impurity, ये दोनों ही इसमें present होता है, metal भी present है, impurity भी present है. अब metal जो है उसका solubility in the melt is less. So it will start converting into solid and getting collected at the other end where the temperature is lower. Okay, solid pure metal. ये जो portion हम दिखा रहे हैं that is solid, that is pure metal getting collected on the left hand side. So have you understood this? Zone refining is this method. Impure metal you have taken, okay, you have taken this impure metal. Circular heaters are converting the impure metal into the liquid. Now in the liquid you have metal and impurity. Metal ka solubility in that melt is less, so it will get converted to solid form and pure metal is collected. जबकि impurity जो है, impurity is collected in the melt only because impurity की solubility is more. So pure metal will solidify and come to the other side while impurities remain at the other this portion. It will remain in the melt itself. Got it everyone? So this is what we call as zone refining. Okay, and zone refining में जो very important metals like germanium है, सिलिकॉन है, सेमीकंडक्टर्स जिससे बनते हैं जैसे सिलिकॉन है, जर्मेनियम है, गैलियम, they are all purified by this method. Okay, so silicon, these are the metals which are used for preparation of semiconductors. Okay, germanium and say gallium. So these are all the metals which are purified by zone refining process. Okay. The next kind of refining process is called as vapor phase refining. Now vapor phase refining means, what are you doing? Let me take an example. It is called as the Mond carbonyl process for refining impure nickel. So what is done? Nickel, which is impure in nature, it is treated with a compound like carbon monoxide, and at a temperature of 330 to 350 Kelvin, what is happening? They both react together to form a complex NiCO4. Okay, ये complex का नाम है nickel tetracarbonyl. ठीक है, so here you have to write 4 so that the balancing is proper. So nickel tetracarbonyl will be formed here, and this nickel tetracarbonyl at a higher temperature, say 450 to 470 Kelvin approximately, you will find that it decomposes into nickel plus carbon monoxide, and this carbon monoxide again can be used for the formation of nickel tetracarbonyl in the first step. Now you may say, what is the use of it? See, nickel will form the bond with carbonyl compound. Nickel has the tendency to form a complex. Impurity will not have the tendency to form the complex with carbonyl group. So if this is the impure nickel you are talking about, impure nickel, then ये जो complex में जो nickel है, that will be pure nickel free of impurity. Impurity is not getting converted into the carbonyl form. Only nickel will get converted into carbonyl form. Okay, so this is the nickel tetracarbonyl first form, and then this nickel tetracarbonyl can be decomposed at a higher temperature, giving you nickel and carbon monoxide. So now what you have obtained is pure nickel. ठीक है, same principle use करने से you can even purify zirconium and titanium, which is called as Van Arkel method. Van Arkel method for the purification of zirconium, which is Zr, and titanium, which is Ti. Okay, zirconium and titanium. Okay, So there you are actually what is doing, zirconium, you treat it with 2I2 or iodine, okay. It forms the complex ZnI4, okay, sorry Zn nahi ZrI4, okay. This complex is formed ZrI4, and this ZrI4, it is decomposed on tungsten filament. It is decomposed over tungsten filament to Zr and I2. Got it? So this is also carried out at high temperature, at it, that is 870 Kelvin, okay, and 2075. This is 870 Kelvin and this temperature is 2075 Kelvin. Very high temperature. Tungsten is the only metal which can withstand very high temperature. So it is carried out, the decomposition process is carried out on the tungsten filament. ठीक है, उसी तरह से you can even talk about titanium, okay, with the 2I2 giving you TiI4, and then decomposition, that also at high temperature you will get Ti plus I2. Here also the Ti is able to form the complex with I2, not the impurity. So here TiI4, okay, complex will be formed where you have pure titanium. Then you can decompose it and you get the pure Ti. Okay? Follow this. So these are the two different methods for refining, which we call it as refining by zone refining process and vapor phase refining. अगर निकल का refining process के बारे में बात कर रहे हैं, then it will be Mont-Carbonell process. If you are talking about the refining of zirconium and titanium by the vapor phase refining, then that method will be called as Van Arkel method. Okay, note down. The next method for the separation of the metal from its impurities is chromatographic method. Okay, chromatographic method. Now, chromatographic method is based on the principle of adsorption. You know, adsorption we have learnt in the 5th chapter. Adsorption is a process where you have one substance being stuck up on the other substance. It is a surface phenomenon. It will get stick on that surface. The surface on which the substance is stuck is called as adsorbent, other is the substance is called as the adsorbent. तो ये principle use करके ये separation carry out करते हैं. Okay. Now you can use different kind of chromatographic method where you have gas chromatography हो सकता है, column chromatography हो सकता है, paper chromatography हो सकता है. So where the adsorbent you will be using different materials. Okay. Now suppose how is the process taking place here? We will talk about column chromatography, that is easier for you to understand. So we will take the column chromatography. Okay. यहाँ पे you have provided a column for the separation to occur. A suitable material, a suitable adsorbent is taken, okay, at this region. A suitable adsorbent is taken, okay. On the top you are adding impure metal. Impure metal you are adding, impure metal melt you will be adding. Now, suppose this metal mixture consists of impurities and along with that metal is also there. Suppose there are 3 components in this impure mixture. Each one of these impurities, no, they will have different tendency to get adsorbed. So, say suppose C is very weakly adsorbed while B is moderately adsorbed and A is strongly adsorbed on this surface column. This column you will take a suitable adsorbent where you will find that these components will get adsorbed there. So the one which is weakly adsorbed, no, जैसे C अगर weakly adsorbed है तो वो जल्दी से flow हो जाएगा. ये mixture में कौन सा impurities is कौन सा components है, let it be A, B and C. So as it starts flowing from here, C will be weakly adsorbed. तो वो सबसे जल्दी फ्लो होके यहाँ पे सपोज इट इज गेटिंग कलेक्टेड एट दिस रीजन, यहाँ पे इसका एड्जॉर्प्शन हो जा रहा है सारे C का. सो हियर यू हैव द C बीइंग एड्जॉर्ब्ड, सेपरेट हो गया. B जो है उसको दैट इज मॉडरेटली एड्जॉर्ब्ड, मतलब यहाँ पे यू विल फाइंड दैट देयर इज एन एड्जॉर्प्शन ऑफ B component taking place, and A which is very strongly adsorbed you will obtain at the, because uska adsorption property is very strong. So here you will have A being adsorbed here. So all these three different components are separated out, isn't it? And each of these component then can be you have to obtain it, no? So they can be, we say the process as eluted, yeah. We call it that it can be extracted from this what we call the column or the adsorbent with the help of a eluent. It is eluted, the C is eluted with a proper solvent. हम एक solvent use करेंगे जो इस C को dissolve कर लेता है या it gets soluble in it, and this solvent will be called as eluent. A suitable eluent will be used. C को उसमें ले लेते हैं and then solvent को vaporize कर देंगे तो हमें pure metal मिल गया, या जो भी हमारा impurity है वो separate out हो गया. B again a suitable eluent is used, it is eluted and it is then वो solvent जो होता है उसको vaporize कर देते हैं and you will get the pure B. ठीक है. A similarly A will also be eluted by a suitable solvent and it will get eluted, separated out. So this method of separation of metal is called as the chromatographic method, okay, where the mixture is separated depending on its speed to move through an adsorbent, या उसका property to get adsorbed on an adsorbent. Okay. So this is the chromatographic method. We have discussed all the different refining processes, and that completes this chapter. The uses and all, you can go through the uses of various metals that you can learn on your own, and this is what we have in this chapter. Okay. Thank you.